Hello, everyone, and welcome to the Anti-Doping Podcast, brought to you by the Partnership for Clean Competition. I'm your host, Dr. Marie McNeely, and today we are joined by our guest, Dr. Andrew Jones. Listeners, Andrew is the CEO and co-founder of Activated Research Company, a company dedicated to creating new products to make chemical analysis easy and accessible. And in our conversation, we are going to talk more about Andrew's career, the innovative products that he's developing at Activated Research Company, and also how their products can be used to advance anti-doping. So, Andrew, we are so excited to have you with us today. Welcome to the show. And how are you?
Well, thank you so much. I'm excited to be here. I'm doing fantastic today. How are you?
I'm doing great. Thanks for asking. And I'm looking forward to talking about a variety of topics with you today. So can you maybe start by just telling us more about yourself and your role there at Activated Research Company?
Yeah, I would love to. So I'm a scientist first. I got my chemical engineering degree, undergrad at the University of Minnesota, and then hopped over to University of California, Berkeley, where I did a PhD in chemical engineering, studying catalysis and how to make biofuels. And then I became an entrepreneur and continued my focus on chemistry and energy and founded Activated Research Company, which we're talking about today, in 2014 because of some of those analytical challenges that I found during my PhD.
Fantastic. So your current role at the company, I guess, what does an average day look like for you?
Well, as the CEO, I wear many hats still. We're not a huge company. Typically, I have partner calls. I have meetings with my team, whether it's the sales team or the ops team who are building, or even the R&D team working on new products. That's where my excitement lies, is on the innovation front. So I try to spend as much time as I can in the new product area, whether that's working on products here or talking to people out in the field about what their pain points are and how we can hopefully help them.
Wonderful. So I'd love to talk a little bit more about how this company got started. You mentioned kind of just a point in the timeline there of your career, but can you really tell the story of how and perhaps why you decided to launch this company and maybe leave the traditional academic career behind?
That was a decision I made back in 2014. So I was finishing up my PhD in chemical engineering at Berkeley, and I had a few opportunities. I could go into industry and work with oil and gas or chemicals or even in the battery area. And I really leaned towards the entrepreneurship path. I think it's just kind of my demeanor, or what excited me about creating something new and building something from the ground up like a company was exciting. And so in 2014, I partnered with my co-founder, who's a local entrepreneur in the Minnesota area. And his deal was he'll put all the money in and I do all the work and we'll split the company. And I said, that sounds like a great idea. Let's do it. And we both had large interest in alternative energy and biofuels and how we can help there. So I had been working on catalysis research at Berkeley, specifically around biofuels, taking methanol to gasoline or methanol to olefins, building blocks of chemicals. And that's a common renewable pathway to take biomass and make fuels. And one of the things I saw during my research was that it's very difficult analytically to measure all the different compounds that you make in a renewable fuel, because there's a lot more oxygenated compounds or compounds that contain oxygen than would be in a fossil derived fuel. And that posed a lot of difficulties. And I saw an opportunity there to create a company that solved some of those analytical challenges and make it easier for scientists to measure those kind of novel compounds that we were making from bio-based products and fuels. That was the story. I moved back to Minnesota. A lot of the Californians didn't even know where Minnesota was and thought I was crazy. We loved California, but it made a lot of sense for myself and my family to move back. And we started the company here 8 years ago, and we've been growing ever since.
Oh, very interesting. And I understand that the products that you actually create there have applications that span a wide variety of industries. You mentioned a couple there, but also anti-doping. So can you talk about just some of the different industries and applications that you're exploring?
Yeah, certainly. I got into this industry technology first. We had an idea specifically around biofuels, and then we quickly realized it could be used in a number of different industries. So we created our first product, which we call the polyarc, and launched it into this biofuels area, and then started to learn that there were similar challenges in other areas. So we started to sell into the chemicals industry for chemical manufacturing, into the oil and gas industry, food and flavor, even as fruits off gas, ethylene or carbon dioxide or carbon monoxide, you can measure those as a surrogate for how ripe or expired those fruits are, or even flavor and synthetic or natural flavors, also pharmaceuticals and manufacturing. So really, it's been fun to see how analytical tools are used across the globe in different areas. And I'd like to say I knew that going into this company, but I truly didn't. I've learned a lot along the way.
That's really cool. And you mentioned this polyarc specifically, and I think this product is really cool. It's a 3D printed microreactor. So can you tell our listeners a little bit more about the polyarc system, what it is and what it can do?
The polyarc was our solution to the biofuels problem. So when you're analyzing a biofuel from cellulose or a biomass source biofuel, there's often a lot of oxygenated molecules. And so the polyarc was our answer to this by basically creating a reactor that is miniaturized and can go onto the analytical equipment that people use. So the machine that everyone uses to analyze a wide variety of things is called a gas chromatograph. And for those listeners that don't know what that is, it's basically just a big box or oven that allows us to analyze different compounds. And you've probably seen these on like CSI TV shows where they press a button and they get an answer of, this is what's in this. Well, our device goes onto that machine and makes the analysis process much easier, either by increasing sensitivity to certain molecules or by increasing the uniformity of the response. So you can limit or even eliminate these calibration steps, which can be very timely or costly or even impossible. And also makes it more green, the whole process, because you can use less solvents, less chemicals when you're doing these analyses.
Very interesting. You mentioned this is kind of a miniaturized system. How big is it?
It's pretty important for everything to be tiny in this analytical world. We're using very small amounts of sample, and you don't want to, for lack of a better term, dilute that sample or broaden it to lose sensitivity. And so the actual microreactor is about 2 inches by 1 inch, and it's a stainless steel body that we use a process called direct metal laser sintering. So it's a form of 3D printing where they take a metal powder and then use a laser to sinter the metal layer by layer, and you can make very complicated geometries. So we took advantage of that pretty early on. And in 2014, it was a pretty new process, especially for reactor design. I don't think there was anyone else that had a commercial 3D printed metal reactor at the time. And so we used that process because we could get really small geometries and very complicated geometries to be able to put our catalyst into that reactor.
That makes sense. So it sounds like the size is definitely a benefit. What other benefits does this polyarc system offer compared to other solutions that might be available?
There's a lot of different detectors and solutions out there for gas chromatography. And a GC or gas chromatograph is used for everything from analyzing cholesterol in blood to analyzing the VOCs in our air. VOCs are volatile organic compounds. So people typically are using mass spectrometry or flame ionization detection. For the polyarc, it's actually an add-on that improves the flame ionization detector and can be used complementary with a mass spectrometer to get complementary information.
Well, that makes a lot of sense. And it sounds like there are definitely some key benefits for this product. Can you talk about maybe some of the other products that Activated Research Company has developed? You've been quite busy over the past couple of years.
Yeah, thank you. It's funny that you say that. The first trade show that I went to, we launched the polyarc reactor. And one of the first people that came up to us was a guy by the name of Stan Stearns, who runs a large company in this space as well. And he said, you got to keep innovating. You can't be a single product company. And he was completely right. And so I took that to heart and continued to innovate. We created a small methanizer, another product that we call a jetinizer, which is essential for greenhouse gas measurements, so measuring CO2, methane, and other pollutants in the air. That jetinizer is sold directly as well as through Shimatsu for their greenhouse gas analyzers. We also sell that product for ethylene propylene analysis, looking at carbon monoxide, which are important building blocks for the plastics industry. And then we also created a few other products. One is the isotope reactor that I think we'll talk about a little bit later as it relates to anti-doping. And then also we have a GC by GC modulator, which is a way to increase the number of species or chemicals that you can analyze in a single run. And then lastly, we've been developing a detector for liquid chromatography over the last 4 to 5 years. And that research was funded by the National Science Foundation because there's a lot of pain points in the liquid chromatography world in terms of invisible compounds or certain compounds that are difficult to find standards for. And so we worked many, many years tirelessly to develop this new detector, and we just released it about a year ago, and it's pretty exciting. We've got applications in polymers analysis and potentially pharmaceutical drug development, as well as carbohydrates and sugars. So we keep moving the needle, and we've been fortunate as well to work with the PCC, or the Partnership for Clean Competition, to develop isotope and a new product that we're working on for breath testing, which I think we'll go into a bit later.
Absolutely. I appreciate you giving us an overview of just kind of the portfolio of products that you have. And we touched on just the wide range of applications for some of these particular instruments. And I'd love to circle back to anti-doping and dive into some of the details there. So how did you, Andrew, specifically get interested in anti-doping, or maybe discover that the work that you were doing was relevant for this field?
So I could trace it all back to a trade show we went to. There's a Minnesota Chromatography Forum. And of course, we're in Minnesota, so this is something we go to every year. And a guy by the name of Larry Bowers, who was on the board of PCC, was giving a very interesting talk about his work in anti-doping at that conference. And we saw that talk, and actually a colleague of mine went up and spoke with him afterwards. And he was specifically looking for a low temperature combustion reactor that was incredibly fast. And that's right in our bailiwick. That's what we do well. The PolyArc is actually a combustion reduction reactor. It has 2 different catalysts in it. So that was something we thought we could sort of immediately help them with. And we got connected with Larry, and he connected us through to the PCC, and the rest is history.
And it sounds like that was the door then to starting to apply for some of these PCC funding opportunities as well.
Exactly right. Yeah. So the first one was this low temperature combustion reactor for urine analysis specifically. And then after we were successful with that, we moved on to this other one with breath testing.
Absolutely. And the Activated Research Company has received support from the Partnership for Clean Competition, as you mentioned, from the Translational Research Fund specifically to create this new reactor for use in anti-doping testing. So can you tell us a little bit more about this new reactor that you've been working on and how it differs from the products that you've created previously?
The motivation behind this was specifically urine analysis is used for testosterone testing in athletes, and to be able to see if they're taking testosterone or other steroids of abuse in sport. So they take a urine sample and then they analyze that for the levels of those steroids in their urine. And the current method to do that takes a decent amount of time, and that can slow down throughput as well as increase the cost of that test. And so there was a goal to increase the speed of how they're able to do this. And one of the limiting factors that was identified was this reaction step, that when you analyze testosterone, you have to actually react it and combust it to CO2 so you can measure the isotopes present in CO2 or in the carbon from the testosterone. So we took on this project to try to make it smaller and faster, essentially. And that was already kind of in our wheelhouse with the PolyArc. But in this case, we were pushing the limit even further to sub 200 millisecond timeframes or even 50 millisecond timeframes for how fast we needed to react and create what's called a peak in gas chromatography. So we worked a few years on this, iterating through different designs to try to create a reactor that could do this, and we're successful.
That's absolutely phenomenal. You mentioned you got it down to, we're talking 200 milliseconds down to maybe even 50 milliseconds, depending on the reaction. What was the time you were working with before? You said a decent amount of time to do this, particularly in the reaction step.
Typical GC peaks are around 1 to 6 seconds or 1,000 to 6,000 milliseconds. And we had done pretty well with the PolyArc. We're able to get nice peaks at those widths. And then in order to get to these fast GC or even comprehensive 2-dimensional GC, you really want to get down to that 100 to 50 millisecond time frame. So to get there was difficult because there's so many trade-offs when you get down to that scale. You can reduce volumes, but then you lose catalyst active sites. And you can also reduce catalysts, but then you can't convert as much. So there was all these trade-offs. And then when you get to smaller and smaller flows, you have less flow to kind of sweep the volumes out of that reactor. And you can get what's called axial dispersion, which can cause all sorts of issues with your analysis and your accuracy. So we did have a lot of iterations back and forth with a team at the University of Texas, Austin with Tom Brenna and Herb Tobias, and we iterated back and forth, and they were excellent to work with, and were able to get down to those really fast reaction and flow dynamic ranges.
Interesting. Now, are these unique challenges for this particular anti-doping application, or are there other ways that maybe this product differs from some of the things that you've worked on previously?
This was pretty unique for us. Well, specifically, it was the only combustion reactor we had. We were making CO2 instead of methane, but the real challenges were this necessity for speed and accuracy, and also complete conversion, because we were measuring isotopes and not just concentration of CO2 or methane. You can get fractionation is what it's called, where if it's not completely converted, you can get isotope effects or kinetic isotope effects that can hurt your accuracy and your precision and all of that. So it was very unique in that sense that we were really pushing the limits on a lot of different fronts and also going smaller than we ever had. We actually reached the limit of what we could do with 3D printing and had to invent new ways to go even smaller with our geometries there. It was a fun project.
That's really exciting. And I think developing these new analytical tools involves a lot of research, a lot of iteration, a lot of trial and error, sort of like you mentioned there. So can you talk a little bit more about what this process has been like for you and maybe where you are in the process right now at the moment?
I enjoy it quite a bit. I enjoy kind of the fuzzy front end of innovation where there's a lot of unknowns, but also a lot of possibilities. I think one of the hard things in the analytical area and why there's not a lot of companies doing innovation here, it's very expensive to do innovation in analytical chemistry because the equipment can be very expensive. The analytes can be very expensive, and you need very highly trained scientists working on these projects. It's also very time consuming because results can take a while to get. A single gas chromatograph run can be anywhere from 5 minutes to 120 minutes. And so you might have to wait 120 minutes before you see whether what you did worked, and you might want to repeat that to get some reproducibility. So definitely cost and time. And at times it can be very disheartening. You can try something and then there's unintended consequences that you hadn't thought, and you have to kind of go back to the drawing board. So that's on the technical side. It's the difficulties there, but also on the market side, the analytical chemistry world is dominated by a few very big 800-pound gorillas. And that's good. They make great products. However, it's hard to innovate or break into that space because everyone who's doing work will just call up one of these large OEMs, and that's kind of how they get their source of new technology and new information. So as a smaller company, getting market adoption and awareness can be very difficult.
Definitely. Well, thank you for walking us through this process and the work that you've been doing there. And we talked specifically a lot about this new reactor that you're developing with PCC funding, but you've also received a PCC research grant separately in 2019 to examine methods for analyzing exhaled breath and anti-doping testing. So can you talk a little bit more about this project and what the aims of this study were?
As I said, we looked at urine as a matrix to study drugs of abuse. And the motivation behind this was to look at alternative biological matrices that were ideally less invasive than even urine, or especially than blood. So breath was very interesting from that standpoint. You can imagine nobody likes to give a blood sample, and people also don't like to give a urine sample. In a lot of these sporting events, the athletes have to be watched while they go to the bathroom into a cup, and that's not very fun for anybody involved. And so the idea here was, could we use something like breath or saliva where you blow into a device and you quantify what's coming out of the breath, and can you see certain drugs of abuse and be able to tell whether people are either on that drug of abuse or have been previously. So that was the motivation and what we applied for and were awarded.
Absolutely. And can you tell us a little bit more about where you're at with this project and if there are any findings that you're able to share at this point?
So we're definitely still in the midst of doing the research for this, but things are going very well. The results are looking very promising. One of the things we hadn't understood as much is how well can you aerosolize a lot of these large molecules. Some of these large drugs of abuse, like steroids, corticosteroids, have very high boiling points, and you wouldn't expect them to be present in breath just from a volatility standpoint. But we've seen that you can aerosolize a lot of these, and then we can also detect them using our device. And so that's kind of an exciting result and one of the risk factors that we knocked out early on.
Phenomenal. And we touched on just some of the challenges in this area or space of developing new technology for chemical analysis. And I think there are a lot of different challenges when you're completely pioneering new instruments for use in chemical analyses. So can you talk about what are some of the biggest challenges that you think you've faced?
Well, yeah, I definitely touched on some of those, the big technical and market ones. In addition to that, for this specific project of breath testing, there's a challenge with trying to decide which equipment to target for the analysis piece. So there's a trade-off between picking instrumentation that many labs have and can afford globally, but they may not be the latest, the greatest, or the most sensitive, versus the other way is to go with the best, latest, and greatest $1 million machines that only a few labs in the world can afford, but you might get a factor of 10 or 100 times more sensitivity. And so that's a challenge on our side, is trying to decide which instrumentation to target for our products to add on to, and will they be accessible to the general public or to most countries in the world.
Absolutely. And I think the accessibility challenge is huge in anti-doping as well as a variety of other fields. And we mentioned specifically when introducing your company that that is part of your mission to make these chemical analyses more easy and more accessible. So what are some of the things that you think you guys are able to do, things that you keep in mind as you're developing new products to really achieve this mission?
Yeah, the accessibility piece has been a long-term goal of mine. And I'll say, I think there's still a lot of progress that can be made in making analytical equipment more accessible to more people. We start by looking at the problem from a first principles approach and try to strip off any excess and keep it as simple as possible. And then we try to build up a technology that's as simple as it needs to be. And we also are able to take advantage of new technologies like 3D printing, new materials that are coming out that either give us cost savings or performance enhancements, and then also just novel design approaches that we've had experience with. So through all of those things, we're able to make technologies that are hopefully accessible to the broader global market, as well as simple to use and simple to set up. What makes us unique and our products unique is most of them are add-on products. So they're easy for anyone to install and then use. It's kind of like the Nest thermostat, where they took that model of let's make thermostats user installable. We've done a very similar thing with the PolyArc and some of our other products, the Jetinizer especially, is that any user can install that. We have video tutorials on how to do that. And that makes it easy for us to send one to India or to South America, and anyone can look at our videos and then install and use the product themselves. But we also have non-GC users in our company that we force to test our products and make sure that they are generally intuitive. And if not, can we improve that?
Oh, phenomenal. It sounds like you guys are doing great work. You've got some wonderful accomplishments, but I'd love to talk about the future as well. So, Andrew, what are your plans for the future of Activated Research Company?
My big three are growth, innovation, and partnerships. So we're, like I said, not a huge company. So we're looking to partner, and we're talking to a number of people right now. We've got a lot of great distributors and channel partners already. So we partner to grow, but we also innovate, and we'll keep creating new products that we think are going to be useful, and listening to our customers specifically on their pain points and what they'd like to see in the future.
Oh, wonderful. And we talked about some of the challenges. If we took away the barriers, the things that normally hold you back or cause you pain, and gave you all of the resources you could dream up, Andrew, is there one particular problem in chemical analysis, or maybe in anti-doping specifically, that you would most want to solve?
If we had all the resources imaginable in the world, obviously I'd be having a lot of fun innovating. And I think where my head would immediately go is to faster, cheaper, and less invasive health screening. And this relates a little bit to the breath testing work that we're doing in terms of making anti-doping testing less invasive. But I think this could pertain more ubiquitously to health in general. For all the wrongs that Theranos did, they actually had a good business model of, can we reduce the amount of blood that's needed to do certain types of tests? I think we can go even further than that and look at other matrices like breath or saliva or things that are less invasive and get more regular testing of people. I don't know if you've seen, there's a lot of news articles about dogs that can smell Parkinson's, or they can smell cancer in people's breath or on their skin. What that means is that there are chemical markers out there that we as humans can't detect, but that dogs could, and then therefore theoretically we could with instrumentation. So with infinite money, we could do this. We could take breath or another matrix and we could screen for hundreds or more of these conditions. And I foresee a future where we're doing this monthly. We walk down to a store and breathe into an apparatus, and it's a cheap, quick test. And it tells you if you're pre-cancer or if your heart's starting to fail because it picks up on those biomarkers. So it's kind of the tricorder from Star Trek approach, where could we scan people and determine what things are failing and use chromatography and chemical analysis to do that? And I think the answer is yes. There's nothing stopping us technically. It's just money and time.
Absolutely. I think there are some really exciting possibilities in this space and with these kinds of technologies. So we appreciate you dreaming big with us on the show today. And I know we covered a lot of ground, Andrew. If our listeners are intrigued and they want to learn more about you and more about your company, what is the best way for them to do so?
Yeah, I would point them to our website, activatedresearch.com. We also have a presence on LinkedIn where we try to post cool news that's coming up. And then also we're building our YouTube library, and we're starting to do more interviews with scientists and people around the world that are using our technology or just using chemical analysis in general and pushing the limits of science. So that would be a great way to follow us as well.
Outstanding. Well, listeners, definitely get connected. Check out these resources. And Andrew, thank you so much for your time and your insights today.
Thank you, Marie. And thank you to all the listeners out there. This has been a blast.
It's been a pleasure to have you. Listeners, wonderful to have you here as always. And if you haven't already, it would mean a lot to us if you could subscribe to our show on your favorite podcast platform. And listeners, please note that the Anti-Doping Podcast features a wide variety of clean sport experts, and episodes may include statements and or viewpoints that do not necessarily reflect the views or values of the PCC. Thank you, and we look forward to seeing you on the next episode of the Anti-Doping Podcast.